Good day, everyone. My name is Frank Maddox. I'm the Global Chief Medical Officer for Fresenius Medical Care, and I'm pleased to welcome each of you to the Life 2021 webinar series. This series of 18 webinars over the next year begin today and represent quality content that's relevant to the clinical practice of nephrology. We'll be interactive with you, our guests, through Q&A sessions, and will help you stay current with the advances in clinical practice within our field. The webinar series is organized and hosted by our chairman, Professor Dr. Christoph Wanner from the University Hospital in Wuerzburg, Germany, and Professor Dr. Peter Stenvinkel from the Karolinska Institute in Stockholm, Sweden. The 36-member faculty, whom many of you will recognize, come from Europe, the United States, and Canada. Fresenius Medical Care is proud to sponsor this educational series that helps us all understand and stay current with the advances and active debates that are within our field and clinical practice. With that, I turn over the program to our chairman, Drs. Wanner and Stenvinkel.
Ladies and gentlemen, dear colleagues, and good morning, good afternoon from wherever you are watching us. Hello, Peter. My task today is to talk about the medium-term future of nephrology in Europe. My name is Christoph Wanner. I'm a professor of medicine and nephrologist at the University of Wuerzburg here in Germany. The task is a difficult one, and I was looking into the crystal ball recently, and you see the paper the ERA-EDTA Council issued just recently, and this paper started with a survey of European nephrologists with key questions on kidney care and kidney research in Europe to understand the impact of alterations to organization of kidney care and of advancement in technology. The total amount of nephrologists responded were 825 members of the ERA-EDTA, and they replied. And the results have several implications to the future of care and organization for the subspecialty of nephrology in Europe. So overall, they felt that maybe nephrology will divide into three subspecialties, questions mark. Nephrology, dialysis, and transplantation. Nephrologists mainly care about diseases of metabolic or immunologic origin, rare and genetic ones. Our colleagues working in dialysis centers, they have attached low clearance clinics where they bring transfer patients into hemodialysis or peritoneous dialysis programs, and also those who care for transplantation for pre- and post-kidney transplantation care. Nephrology is encompassing aspects of endocrinology, cardiology, immunology, oncology, and neurology. The highest number of comorbidities are accumulated among all medical specialties in nephrology. Our patients are the most complex and most comorbid. Many facets of care makes nephrology a complex medical specialty. And our students tell us sometimes nephrology is a difficult subject. I don't agree with this. I think when you have done a number of years of nephrology, you feel pretty well. Changes in the ownership of kidney care currently and in the future, and changes of ownership of dialysis centers, public versus private, is ongoing. So many things are changing. Advancements in technology and computing, diagnosis and therapy, and new approaches to treatments are introduced. So dialysis doctors feel that they want and will work in low clearance clinic once the GFR falls below 30, They transition patients into kidney replacement therapy smoothly. They work together with kidney dietitians and have the hemo and peritoneal dialysis programs in place. They are specialists about CKD, mineral and bone disease disorders. They know a lot about anemia, volume, salt and water, uremic toxins, vascular excess, malnutrition, frailty. They are good internal medicine doctors to understand all this and also help our patients when they develop malignancies. Hygiene is a very important topic in dialysis, and infections are cared for in our patients. We have to look over all technologies, the water treatments, the devices, and now the new features with telemedicine. We do a lot of social care for our patients, and we participate as dialysis doctors in clinical studies. The nephrologists in the hospitals mainly think that we care for chronic kidney disease, the rare diseases of nephrotic syndrome, genetic disorders, nephropathology is the topic. We care also at intensive care units for acute kidney injury. Intensive care and continuous renal replacement therapies are under the care of hospital nephrologists. We do diagnosis and classification of kidney disease, are also specialists for hypertension, diabetes, know a lot of lifestyle, and also more and more about heart failure in our patients. And of course, immunology, progression of kidney disease and regression is under our care. We are good internal medicine doctors and look over the many comorbidities, the accelerated vascular aging of our patients. We do cardiovascular prevention, working in multidisciplinary teams, do research in networks, and we have the facilities and the clinical trials offices, research and development in universities and large hospitals is at the front. But then also our colleagues in transplantation care about living donation, do preemptive transplantation, the organ will be allocated, and look for the pre-transplantations listing of the many patients. Know a lot of immunology and immunity, immunosuppression, and the pharmacology is very complex, actually. The post-transplant follow-up is important for many, many years of our patients. We are very good internal medicine doctors, do vaccination programs, hygiene, infection, and of course also transition back patients into dialysis, nephrology, and are present in intensive care. Clinical studies and research and development is also important in dialysis. So finally, I was thinking, or the group was thinking, a dialysis doctor, what can he do really, and has also to do in nephrology and transplantation? And it's not the entire program, and it's impossible to follow all the new dialysis, the new developments, but some knowledge about nephrotic syndrome, diagnosis and classification is currently under their care, and it's different among the countries in Europe. So dialysis doctors also bring their patients into dialysis programs and need to understand some of the basic things of transplantation. All is to cover appears to be too complex for most of the surveyed nephrologists in Europe. I think we should be connected among, we should not be splitted like in cardiology, some of the subspecialties. We need to stay together, but the entire field becomes more complex, and we have to move over the next years, the medium term, into understanding the different sections in the care of our patients. So I think I'm coming to the end, only highlighting again nephrology departments at university hospitals, community hospitals, large kidney centers. They have an infrastructure, they can care for everything, and also for the new, very new, expensive medications in multidisciplinary teams, and they can work as reference centers. The dialysis centers are mostly freestanding for outpatients care and have, as I mentioned, the low clearance clinics under their care and do all the social care and are at the bedside of the patients. The transplantations will also be in large centers, mainly departments at university level or community level sometimes. This is different in different countries in Europe, and can also be cared in large kidney centers when specialists are available. This was a short overview where nephrology is moving, and it may be totally different in 10 or even 20 years from here when we have the digitalization full in place. So thank you for your attention and I hand over to Peter, and please continue.
Thank you so much, Christoph, for looking into the crystal ball and giving us some clues what will happen in the medium near future. My name is Peter Stenvinkel. I'm a professor at nephrology at the Karolinska Institutet in Stockholm. And before I start my talk, I will just give you some housekeeping rules. And I think the most important is that it's possible for you to submit questions through the chat window, because both I and Professor Wanner, we want to address your questions after our talks. So with this, I think it's time for me to start my presentation. And I will talk to you about something that is very timely, something that is important for all of us, and that is the health of our planet. COVID-19 and biomimetics. What saves the planet will save our health. So we have all this prevalence of burden of lifestyle diseases, including chronic kidney disease, but there are many others such as obesity, diabetes, atherosclerosis, and cancer. These are diseases that accumulate as we get older. And it's evident that after the age around 65 and 70, there is a dramatic increase in the death risk from cancer, cardiovascular disease, and Alzheimer. These diseases seem to be quite different, but they have one thing in common, and that is that they have a chronic inflammatory response, thought to be an accelerator of biological aging. Later in my talk, I will address the recent pandemic of COVID-19, and you see that also for this disease, there is a dramatic increased death risk above the age of 70. So Homo sapiens, which actually means the wise man, is responsible for the ongoing 6th major mass extinction, something you can read about in this PNAS paper. And the human impact on the environment due to global warming, pollution, lack of clean water, deforestation, habitat loss, and illegal animal trade will have a major impact not only on the environment, but also the panorama of diseases. So let's start to talk about global warming. And this is terrifying data showing the temperature change in the last 50 years, and since 1880 there has been an increase in the temperature of 1.16 degrees Celsius. And we are now getting more and more reports on the impact of the global warming on our health. We nephrologists have known for many years that climate change may cause epidemics of chronic kidney disease in warmer areas of the planet. But this recent Israeli study show that global warming may also affect pregnancy outcome and increase the risk of preeclampsia. Global warming and the epidemic of obesity are strongly associated, and we know that heat stress activates the fructose vasopressin pathways. Similarly, there are more reports showing that low water intake in relation to heat stress may increase the risk of type 2 diabetes. This review article shows the influence of increasing temperature on blood pressure management in Asia. And there are other papers like this one showing also increased vulnerability patients with chronic obstructive pulmonary disorders due to global warming. This is scary, but even more scaring are these data that were presented in Nature this spring about the projected timing of abrupt ecological disruption from climate change. So under a high emission scenario that we see today, abrupt, sudden and severe biodiversity losses will begin before the year 2030 in tropical oceans, and it will spread to tropical forests and higher latitudes by the year 2050. So we are running out of time. Pollution is also something that may affect our health. I will here draw your attention to this recent modeling study that was published in BMG Global Health on the global and national burden of chronic kidney disease attributable to ambient fine particulate matter air pollution. And this study shows that fine particulate air pollution will be associated with more than 3.2 million cases of chronic kidney disease each year. And this will be preferably in the low income and lower middle income countries. So maybe we should not only wear a face mask to protect ourselves against COVID-19, but also this may be a protection against chronic kidney disease. So lack of clean water is a major problem. And here we have, as nephrologists, a responsibility to use more green dialysis, and it can be estimated with about 3 million hemodialysis patients on this planet. More than 230 billion liters of clean water are used, and 1.3 billion tons of plastic waste are generated every year. So dialysis service and industry must urgently start efforts to advance sustainable kidney treatment technologies that minimize water usage and the generation of waste. Deforestation is another major environmental problem. And I would like to provide you with this example, how important this is. This is a Brazilian snake, Bothrops jararaca, and you as nephrologists know that in the venom of this snake was found a substance that later became captopril, ACE inhibitor treatment, and of course this has been a major advancement in the treatment of chronic kidney disease. But reading this review, I learned that less than 0.01 of snake venom toxins have yet been identified and characterized. So I think the snake venoms is an enormous valuable therapeutic tool for life saving. And about 35% of the medicines we use today have originated from nature, and the development of future drugs is therefore much dependent on the preservation of nature. And especially since the Amazonas present the largest biodiversity in the world with more than 50,000 species of higher plants, deforestation of Amazonas must be prevented, not only for environmental but also for health reasons, because the Amazonas may be our future pharmacy. And it's extremely worrisome about the deforestation that is currently ongoing in this world's largest rainforest, not only for climate change, but also for the possibility to develop future drugs. Let's move on and discuss habitat loss and illegal wildlife trade. And here I'd like to draw your attention to this paper published in PNAS 2018. stating that mammal diversity will take millions of years to recover from the current biodiversity crisis. And biodiversity is actually much more than the number of species. If you lose one specific species, you will also lose unique evolutionary history in the tree of life for these species. And it will decrease the possibility to develop new drugs and learn from ingenious solutions in nature. So we have all these chronic burden of lifestyle diseases associated with inflammation. You can state that they reflect a disturbed interior milieu. But now we also need to learn what the effects of a disturbed exterior milieu be on the panorama of diseases of the future. And here I see an opportunity, and we need to embrace this concept of planetary health, because in the nature there are numerous ingenious solutions that have been developed during the evolution that can be used for developing new treatment strategies for human diseases. So we have all these burden of lifestyle diseases, and discussing this with veterinarians, biologists, ecologists, and zoologists, it's evident that there are many animals out there that already during evolution have developed ingenious solutions for these diseases. For example, the extreme and interesting cancer resistance that you will find in elephants can teach us a lesson. We have the giraffes, which tolerates extremely high blood pressures, 350 above 140, but they never get stroke or kidney disease. And then we have the hibernating bears that don't pee for periods up to 5 to 6 months, but never developed any consequences of renal failure. So I would think that biomimetics could be a future very nice opportunity to use novel treatment strategies instead of the experimental animal experiments that we are currently doing so much about. And it's been discussed widely that animal data is not reliable for human health research. A PNAS paper described that control laboratory rodents, they are metabolically morbid, and more than 90% of animal experience actually fail to lead to treatments for humans. And with this, I would like to move to virus and COVID-19. And we know there's enormous diversity of virus in wildlife. Animal virus have a really high host plasticity, and then of course the risk for the spillover of viruses to humans are the cause of this pandemic that we are now witnessing. And even before the COVID-19 pandemic, zoonotic diseases were responsible for over 2 billion cases of human illness and more than 2 million human deaths each year. And that include Ebola and HIV, tuberculosis, rabies, and leptospirosis. And finally, we should not forget that all coronavirus infections originate from the animal kingdom. They are zoonotic diseases. We have learned a lot about SARS-CoV-2 the last 9 months. We know that the interferon signaling system is a vital part of the antiviral defense mechanism. This Cell paper shows that SARS-CoV-2 infection drives a much lower antiviral response with lower interferon levels together with elevated levels of chemokines and cytokines. So we have a real therapeutic dilemma, because we have at the same time hyperinflammation and reduced antiviral defense mechanism. And with this, I would like to move on to bats, because they have developed unique defense mechanisms that allow them to be persistently or latently infected by virus. And if you talk about bats, you should remember that bats are actually the only mammal on the planet that are capable of true flight. They can fly, and this costs a lot of energy. The metabolic rate increases 15 to 16-fold in bats during flight, and this is comparable to only a 2-fold increase in birds. And this extremely high metabolism will increase the generation of oxygen-free radicals that may promote cellular DNA damage. And this the bats have to avoid because there's an upregulation of a cytoprotective transcription factor NRF2 in bats. And we know that this cytoprotective transcription factor upregulates hundreds of anti-inflammatory, antioxidative genes. Suggestion that this transcription factor actually is important for protection against severe COVID-19. This is a paper showing a role in the protection against lung injury, paper showing a role for NRF2 to protect against endothelial damage. This Nature paper showed that NRF2 suppresses pro-inflammatory cytokine transcription, so it could be of importance to protect against the cytokine storm. And finally, a recent paper showed that an NRF2 activator actually downregulates the ACE2 and TMPRSS2 receptor mRNA. So this extreme high metabolic rate in bats also promote fever. And this table here shows examples of body temperature in flying bats, and you can find that some bats have a temperature above 39-40 degrees. And for all species, we know that high body temperature is something that is favorable for innate and adaptive immune responses. But bat viruses, as they have adapted to be more tolerant of the fever response, this will cause less virulence to the natural host, but the problem is that if a human with the same virus will get fever, it is not protective. So the impact of the ability of bats to fly is that they have lower inflammation. That is something that may be advantageous for virus replications. So to combat that, the bats have during evolution developed a unique antiviral immune response with high interferon gene expression, so they can control the viral replication. So if you go back to the therapeutic dilemma in the humans, which is hyperinflammation together with reduced antiviral defense mechanism, it seems like the bats have solved this because they can control excessive inflammation. They have reduced levels of inflammatory cytokines and at the same time having unique antiviral responses with high expression of interferon. So they can have a persistent viral infection without having much symptoms, and usually there is not much spillover. But if bats are stressed, such as they will be if they are confined in cages, if there is a destruction of their habitat due to deforestation or during hibernation, there will be a spillover of the virus. Secondary infections, I think this is probably the best example of this. So there is a fungus infection in bats called the white nose syndrome. This paper showed that the intestines of virus-infected bats that also were infected with fungus, they had more than 60-fold more coronavirus RNA than bats with virus alone. So there are more than 1,200 species of bats. The black flying fox, the interferon pathway is always on. You have the Egyptian fruit bat, and here the interferon pathway is only activated during an infection. But taken together, having a really robust interferon system seems to help the bats to have viruses to persist within the bats. So the bat immune defenses drive the evolution of faster transmitting viruses, and this is a problem for Ebola and for the SARS-CoV-2. And while the bats are well protected from the harmful effects of these viruses due to these ingenious solutions, other species, such as humans, we are not. So I would say that bat is they are a nice example of a biomimetic solution. They have this mild asymptomatic persistent viral infections because they can control hyperinflammation. They have a high constitutive expression of interferon. and that there is no problem caused. But if you destroy the natural animal habitats, if there's a climate change, deforestation, pollution, this will be disturbed, and this may promote human zoonotic diseases. So you might remember my first slide when I talked about chronic burden of lifestyle diseases and the relation to chronic inflammation or inflammaging. This science paper recently published showed that this increased inflammation in aging is something that inhibits immunity and affects the responses to infections. So aging immunity, chronic inflammation may exacerbate the COVID-19 infection. And actually, during chronic inflammation, there is usually a slowing down immune system when it is in overdrive, and there are numerous papers showing that as you get older, the interferon production decreases, but especially if you have chronic diseases, there will be severe decline in interferon production. And this may be one reason why this group of the population are so susceptible to an aggressive course of COVID-19. And on top of this Japanese paper, not yet published, shows that the SARS-CoV-2 or 3b is antagonizing interferon. And this may help to explain the poor interferon response in COVID-19 patients. So it's time to me to sum up. And I hope I have convinced you that the COVID-19 pandemic is just a sign of a very poor planetary health. For me, it has the same origin as climate changes, global environmental degradation. In nephrology, we need to advance this planetary health perspective. And we cannot see diseases in isolation because the external environment will shift the disease panorama, and we need to include environmental scientists in the discussions of our diseases. And we should also be aware of the loss of biodiversity in the animal kingdom may have profound changes in our ability to find new treatment strategies for burden of lifestyle diseases. And there are numerous extremely ingenious solutions out there that could help us to treat our patients with chronic diseases much better. Thank you for your attention.
So great paper, Peter. Appreciate it. I think also the audience. We have a number of questions in the chat function already, but until we get these, can I ask you a question by myself? I noticed that you were talking about the very high blood pressure in some species. I think you said giraffes 300.
Giraffe.
And you mentioned stroke. But they should get kidney disease. Why do they not getting kidney disease with such high blood pressure?
Yeah, it's a very relevant question, and this has befuddled zoologists for a number of years. And there is a very active giraffe research project ongoing in Denmark, in which they study this, and they have an probable solution why the kidneys are so well protected against this high systolic blood pressures, because they never get kidney disease. This paper actually showed that there is have a very, very thick renal capsule that they think could be protective against the high blood pressures.
Okay, so some anatomy differences. Yeah. So there is a question coming up, and do you think that there is also a different kind of specialization necessary if nephrology is split into 3 subspecialties? Apparently, this is a question to me. A different kind of specialization, training, education is what you think. Actually, we had not reflected this to go into deeper training in these various subsections. and to learn more about rare diseases, to learn more on progressing transplantation very well. I take this as a thought further to the working group. I think we have to think about. We are continuously specializing ourselves. I think you're right. This may be necessary to go in deeper in some subspecialties of nephrology. Thank you. So I got again a question. The question is, what is your prediction as far as sustaining attractiveness in nephrology as a specialty, if the division into those three subsections is a reality? Very good. We discussed this, and I think we can learn, or Western Europe is learning from Eastern Europe. Western Europe is male-dominated in nephrology. Currently, is transitioning into more women. Eastern nephrology has traditionally more women working part-time, and then they can, in some, for example, in dialysis, can be very, very well adapted and employed part-time, and then nephrology is attractive as a subject when we bring more women working with us together. Peter, what do you think is the attractiveness of nephrology currently in Europe? We do not suffer so much than the United States.
Well, I think nephrology is getting more and more complicated. It may be needed to have these three subsections to be able to cover the whole spectrum of knowledge needed. It is hard for us to stay updated in all three areas, I think, in the future.
One thing comes to my mind is that in the currently COVID situation, we have no congresses anymore. And this is especially attractive for young fathers and mothers with small children. They cannot go to many congresses per year, but they can go into listen to these webinars, what we are doing today. And if the webinars are there for the evenings and longer periods of time, and they can learn, and I think this is also one of the advantages of these webinars for the next younger generation and to bring them into nephrology. So we have a question to you, Peter. How can nephrology contribute to risk management?
Yes, I think what we really need to start is to increase the awareness of the impact of planetary health on the burden lifestyle diseases and for chronic kidney disease. We have already since many years we have done research on the effects of global warming on heat stress nephropathy, and I think the main task for us now is to increase awareness in the nephrology community on how important this topic is, and then to advance this into research.
Good, thank you. More questions? There is one for me about the future education systems for nephrology. Will they be divided into classes for nephrologists, dialysis and transplantation specialists from early on? I think that's a logic consequence. I'm a little bit reluctant to bring us into the field. You are a dialysis doctor and you are the proper nephrologist. What we already heard over the years and we did not like. And I understand the question, a consequence of my talk, but I think we have to reflect about this and not abbreviate that special training to 2 years for dialysis, 2 years for transplantation. A really full-blood nephrologist requires more than a short specialty training to understand the entire complex issues. That's what comes to my mind in a short period of time. Thank you. Peter,
so there's
can
a
you
question
read this question?
Yes. Which unsustainable behavior in nephrology could easily be avoided? And there I would think the first that come into my mind is waste of water and plastics. As I mentioned in one slide, there is an enormous amount of clean water and plastics generated in the dialysis treatment, and I think we need to move rapidly into green dialysis, and this is what I think the major thing we could start by getting more environmentally friendly behavior in our specialty.
There are some good examples from Australia, for example, but the response from the industry sometimes is, wait a minute, you also have to respect hygiene. And we cannot drill down this to nothing without respecting the hygiene. We have to, where the patient is exposed to all these materials and water. So it's a difficult task, I think, but I think we should train hard. You're right.
Yes.
Peter,
so another
one more
question for me. Yeah. Sustainability and environment protection are so important. How to support introducing environmental criteria in tendering for dialysis products and services? And I think here again, this green dialysis concept is something that we need to work on immediately to decrease the generation of plastic waste products and use less clean water. So I think this is like the same answer to the previous question here.
Final word from you, otherwise I have to remind everybody that this live webinar series is continuing. We have another one in 1 week from here at 6:30 Central European Time. And there will be an interesting topic on the renal replacement therapy by 2030. And Dr. Maddox and Professor Cano, I think they are the experts, and they can discuss with us what about the year 2030 and how did we advance the green nephrology in the concept of renal replacement therapy. So I think we thank you all for attending this conference. I hope you found it valuable, and let's see us next week, September 24 at 6:30 again. Thank you.
Bye-bye.